Hello and welcome to Eclectic Classes. This video will help us in correctly choosing between stepper motor and servo motor depending on the application. So let's start. In our previous videos, we have already learned about stepper motor and servo motor including their working principle. Now let's differentiate between them so that we can choose the correct one as per our requirement. Servo motors work in a closed loop control system only, where we get position feedback from a position sensing device, while stepper motors are usually used in open loop control system, but there are some rare requirements where we do use stepper motors in closed loop control systems also. Being employed in a closed loop system, adjustment of gain or tuning is required in case of servo motors, while tuning is not required in case of stepper motors. As stepper motors are usually deployed without an encoder, every time they are powered on, they go for a homing routine. That is, motor completes a routine that resets to a known home position. But in case of servo motors, homing routine is not compulsory as encoder is always there to give the position feedback. Stepper motors have high pole count, usually in the range of 50 to 100, while servo motors have low pole count, that is between 4 and 12. Both the motors provide roughly same torque, but in case of servo motor we have more control over the torque and we can have high level of torque at even high speed. In case of stepper motor we get high and maximum torque at zero speed itself, but with increase in speed it loses its torque significantly, sometimes even up to 80%. Servo motor is more suitable for application where speed is a priority, as servo motors can rotate at several thousand RPM, while a stepper motor runs best at 1200 RPM or lower. While we had a driving mode named micro stepping in stepper motor, in real life application where we need to increase the resolution of the motor movement, servo motors are a good choice, as in case of a stepper motor, micro stepping involves dividing the current between poles to achieve micro steps, which ultimately result in lowering of the torque of the motor. As servo motors need to have an encoder for fulfilling its desired operational requirement, they are costly in comparison to stepper motors, which do not need any encoder. More parts always mean more maintenance, so servo motor will always need more maintenance in comparison to stepper motors. So these were the differences between a stepper motor and a servo motor. Now on the basis of these 8 factors, you can easily choose a suitable motor for your application by trading off between various factors as mentioned here. Do tell me how was the session. I'll be back soon with many more videos. Stay tuned, subscribe to my channel, hit the bell icon and hit the like button. Thanks for watching. Bye for now.